I gave you two homework one and two. After the last class, we're going to consider each of those homeworks, if each of those homework, and then we'll discuss something which is a small digression, importance of mathematics. Okay, even though we are discussing physics. Okay, now mathematics, the only universal language. That is how I coined it. Okay, is the only universal language. You have different continents, different countries having different languages, isn't it? Nigeria having over 500 languages, okay? But over 300 ethnic groups, right? And our lingua franca is, our national language is English, right? Other countries, we have Arabic, French, German, Urdu, correct? Different languages. But then there is only one language that unifies the whole world, which is mathematics. Okay? That's why I said it's the only universal language. I need to digress a bit to talk about mathematics because you cannot understand physics thoroughly without understanding mathematics. Mathematics is intricately and explicitly and implicitly as well imbued in physics. So your background in mathematics has to be very sound. Okay? It doesn't mean if your background is poor, you cannot study physics. You still can, but then you will have to go and make sure that the foundation is mathematics becomes sound. Okay? The language of science, and this is because language of science and applied science disciplines like physics, which is basic science, engineering, which is an applied science, medicine or medical sciences, which is applied life science, they all have something in common, which is mathematics. Okay? And not only the sciences, even the social sciences, they do use mathematics, especially statistics. Okay? Especially statistics, in order to make sense of the data they analyze during the research and what have you. Okay? So mathematics is something that you cannot escape from. Okay? You just have to have some working knowledge, at least. But in physics, you need just beyond working knowledge. You need to have some background in mathematics. And for that, like I mentioned, I need to emphasize on certain aspect that you need to know before we move further. The language, everyday business, the language of everyday business and politics. When you go to the market, give me this. How much? This naira, isn't it? You can use your mathematics to determine how economic something is. You have water, let's say 750 cl. You have 550 cl. You can compare the prices based on the volume and then determine which one is cheaper. Okay? That's a simple application of mathematics. Simple addition, subtraction, and division when you go to buy something is also application of everyday mathematics. In politics, the story is not different. You can hear politicians mentioning so amount of money has been budgeted, so percentage goes to education, so percentage goes to this, goes to that sector. Okay? But more often than not, politicians can use mathematics to confuse people. Okay? How do they do that? Maybe they will say, this year they budgeted there is no escape. You cannot escape, right? Even if AI to solve it for you, you have to understand it clearly. Because change of subject is very important. Now, solve question two here. Y equal x by 2 plus a. Make x. So the formula. So tell us.
Given that y equals to x all over 2 plus a and make x the subject of formula, we will bring the a to this place, and when the plus sign crosses the equal sign, it becomes minus,
Okay.
which means y minus a equals to x all over 2.
Good. And then
And then multiply both sides by 2.
okay. The multiplication here. And then you say both sides. You're multiplying only one side. This side. Yeah. You say both sides. You're multiplying only the right hand side. What about the left hand side?
Yes,
Hmm?
I am going to multiply it,
Okay.
which means 2y minus a equals to
So we
equals
cancel
to
two.
x,
Now we
yes,
have x, right?
which therefore x equals to 2y minus 2a.
Excellent. Or you can even leave it as it is.
Yes.
With 2 factorized. Okay. 2 into y minus a. Excellent. Mariam, did you get it correctly? Good. Check Mariam's solution for question 2. It's correct. Okay. So now let's look at the question 3. This is change of subject. A very simple topic, yet important that we can Okay.
Given that a minus 2 root x all over 3 equals to b,
Make x the subject.
make x the subject.
What do we start?
Mm, we bring b to the
Okay.
next one. A minus b equals to minus 2 root x all over 3.
Look at the sign. This is minus 2 root x over 3. This is when it crosses the equality sign. Is this still minus?
But it has been the question.
No, this one. 2 root x over 3 has crossed the equality sign from right to the left. Will it remain minus? Good. Go ahead. Now what
Then
next?
cross multiply.
Okay.
2 root x equals to 3a minus b.
And then next step.
Divide both sides by 2.
Excellent.
It's x equals to 3 minus a minus b all over 2.
Okay.
Then
Then how do we get rid of the square root?
x equals to 3a minus b with all over 2 square.
Excellent. That is by squaring both sides, isn't it? So you square both sides, square it, square both sides. Exactly. And then go. Maria, did you get this right? Yeah? Maria, did you get this right? Okay, which step? Homework 2, we have usually conversion of units. Okay, so they may appear straightforward, but most physics problems, you realize that some units are not homogeneous. Okay, they are not using one unit system. In the next lesson, lesson 3, will explain the different unit systems in details. Okay, now this, it says convert the following temperature to Kelvin. Okay, temperature to Kelvin. Oh, hello. Come and do the first one. 10 degrees. So from 10 degrees Celsius to Kelvin. You know, Kelvin is the SI unit of temperature, isn't it? So in problems, more often than not, you know, if you have units other than Kelvin, you need to convert to Kelvin first before inputting any value for temperature. Okay, so 10 degrees Celsius.
To convert 10 degrees Celsius to Kelvin, we use the formula K equals to degrees Celsius plus 273.
Excellent.
Therefore, 10 degrees Celsius plus 273 equals to 283 Kelvin.
Good. Okay. Although here you don't need to write 10 degrees Celsius. Okay. Good. Marioma. The second one. So, did you get it correct? Because
Yes.
this is pretty simple. It's direct forward, isn't it? It's straightforward. I mean, you just add 273 to degrees Celsius to convert to Kelvin. What about 85 degree Fahrenheit? How do you convert to Kelvin? Question 2.
To convert degree Fahrenheit to Kelvin, you say degree Fahrenheit minus 32 times 5 all over 9 plus 273. In this case,
So what is this?
it is the formula for getting degree Celsius.
Degree Celsius. So what you did, the first time is converting from degree Fahrenheit to degree Kelvin. Sorry, from degree Fahrenheit to degree Celsius, right?
Yes.
And then adding 273 converts from degree Celsius to degree Kelvin. Go ahead. Go ahead.
In this case, we were given 85 at degree Kelvin. We will say 85 32 times 5 over 9 plus 273. This what is 85 minus 32?
Okay, your calculator is there. Punch it. Your calculator is there. Oh.
Get 43. Then times 5 over
just
9.
take your calculator and punch everything, because this is just simple arithmetic. The physics is finished from here, from the first line, isn't it? Knowing that from degree Fahrenheit to Kelvin, you have to first change to Celsius and then to Kelvin using that formula. Did you get it right? Hello. Okay, so what was your final answer? 302.59. Okay, just put it. 300 and 302. 302, not 32. 302.59 Kelvin. Good. Excellent. So now the next one, it says
convert the following temperatures to degrees Celsius, what we call the centigrade scale as well. Okay, so here we are converting to degrees Celsius. So I think now I can quickly, because based on this, you have a good understanding of this conversion. But one thing you should know is that you have to memorize the formula of the relationship between, degree Celsius to Kelvin and Fahrenheit to Celsius. You have to memorize the formula. Very important. Because here, formulas are not provided during exams. You have to memorize them. Now, convert to degrees Celsius. This is 2A. You have 273. So, simple, as you mentioned, Kelvin is degrees Celsius plus 273, right? And then Kelvin now is 273. So, this is plus 273, right? And then definitely when it goes there, it becomes minus. So degrees Celsius becomes 0. Okay? So this is 0 degrees Celsius. And what is that temperature? Does it ring any bell? 0 degrees Celsius? Yeah, what do you know? What substance do you know that has temperature 0 degrees Celsius? Thermometer? Hello. Thermometer is an instrument for measuring temperature. Ice, excellent. Ice block has temperature 0 degrees Celsius. Okay, the temperature in our refrigerator is usually around 4 degrees Celsius, 4 to 5 or 6. But the freezing section is 0 degrees Celsius, where ice is formed, isn't it? Okay, when the temperature is 0 degrees Celsius, water is transformed from liquid to solid. Do you understand? Now, the second part is 120 degree Fahrenheit. So, 120 degree Fahrenheit to what? This is B, right? 120 degree Fahrenheit to Celsius. We have to use the formula, isn't it? Straightforward. So, what is the formula? Degree Fahrenheit is equal to what? You have to memorize that formula of converting from degree Fahrenheit to Celsius. So, sorry, degree Celsius is equal to what?
5 over 9.
5 over 9?
Degrees Fahrenheit minus 32.
Minus 30. Oh, degree Fahrenheit minus 32, right? So this is the formula. You have to memorize this formula very well. You understand? So all we do now is to plug in 120 here, isn't it? Which is straightforward. 5 by 9 into 120 minus 32. And what's the final answer?
88.
So degrees Celsius is 88. What? 48.88 degrees Celsius. What do you know could reach around 48.88? Could our blood reach 48.88 when we have high fever? Well, I know they say high grade fever can reach sometimes 40. I don't know if it can, maybe 41, but 48, yeah, this is too high. I don't know if that is possible. But water, when you heat it, it can reach even more than 100, isn't it? Can water reach more than 100 degrees Celsius?
No.
It cannot, isn't it? Because it will form steam. Once it reaches 100, it evaporates, isn't it? It changes state from liquid to gas, right? And steam. Between steam at 100 degrees Celsius and water at 100 degrees Celsius, which one is hotter? Which one burns? When you touch it, you feel the heat more.
Steam.
Why steam? Why water?
Because water damages immediately.
And steam?
After
Steam, when it is boiling.
As soon as you open it, come out.
All right, Mariam is correct. Steam burns, you feel the heat more from steam. And there's reason for that. When we reach heat, okay, under latent heat. Because steam has what is called, you are supplying heat, but the temperature is not reading, it's not rising. So that means it has accumulated some of that heat, but it's not reflecting on the thermometer. Do you understand? That is what we call latent heat or hidden heat. Steam has hidden heat. So it's hotter than water at 100 degrees Celsius. But like I mentioned, we'll expatiate more under latent heat. Okay? Now, the next question, it says, convert the following temperatures to degree Fahrenheit. I think this is degree Kelvin. So we first convert to degree Celsius, isn't it? Correct? Yes. By subtracting 273, isn't it? Which is 0. And then from degree Celsius, we use the formula. Okay? We now use this formula which we can convert, isn't it? To change it now to degree Fahrenheit, isn't it? Correct? The second one is in degree Celsius. So we use this formula, isn't it? To add 273. No, wait. Yeah. We okay, it's in. Oh, we want to convert from Celsius to Fahrenheit. So we use this formula straight, isn't it? But the only thing is that we have to make degree Fahrenheit the subject of formula, isn't it? Is that clear? And these are some of the conversions that convert the following quantities. Convert the following quantities to their respective SI units. Yes, convert the following quantities to their respective SI units. If you remember in lesson 1, we started unit conversion, but we are not done with it yet. Okay? Because like I mentioned before we started, that in lesson 3, we will look at units proper. Okay? Look at the different unit systems. Okay? So here, 177 centimeter. Mariam, how do you convert 177 centimeter to their respective SI units? So centimeter is a unit of what? Which quantity? Centimeter is a unit of what? Centimeter is a unit length. Excellent. So and what is the SI unit of length? Meter. So we are converting from centimeter to what? Meter. Good. So when converting from centimeter to meter, how do we do that?
Divide by 100. Divide centimeter by 100.
Because 1 meter is equal to how many centimeter? 100 centimeter. Good. So now we have 177 centimeter. So what? 1 meter is 100 centimeter. Pardon? 1 meter is 100 centimeter. Okay. This is 1 meter. See it here. This is my mic tape. This is this is 1 meter. You can see it. Okay. The graduation is divided into 100 centimeter. Okay. So now what about 177 centimeter? So 177 should be like this, isn't it? Oh, okay. So what will be that in meter? Okay. So we simply divide this by what? 100. And that gives us what? 1.77 meter, isn't it? Okay. And then the second one, 9.5 kilometer. Kilometer is a unit of what? Length as well. So the SI unit of length is what? Meter. So we have to convert 9.5 kilometer to meter. And how do we do that? We have to remember the relationship. How many kilometers make 1 meter, isn't it? And what is that?
1,000. 1 kilometer. 1,000 meters makes 1 kilometer.
1,000 meter? Okay, so 1 kilometer is equal to what?
1,000 meters.
1,000 meters, isn't it? Okay, so now we have 9.5 kilometers. Okay, so how do we convert it to meters? Do we divide?
Times 1,000.
You see, we're converting from bigger unit to smaller unit. If you're converting from bigger unit to smaller unit, then it means that the result has to be more, isn't it? You can only get more when you multiply. When you divide, you reduce, isn't it? In the first one, we are converting from smaller unit to bigger unit, from centimeter to meter. Centimeter is smaller than meter, isn't it? So from smaller unit to bigger. So that's why we divided. Because meter is bigger than centimeter. So that's why you see from 177 to 1.77, isn't it? Do you remember the logic now? Okay. So, but if you do the cross multiplication method I taught you in lesson 1, that will be taken care of. You don't have to remember bigger to smaller, smaller to bigger. Do I multiply or divide? Okay. So the cross multiplication part will take care of that. Okay. But otherwise, because this is like straightforward and simpler and shorter, so we simply multiply, isn't it? We multiply now 9.5 by 1000, right? So which will give us 950, isn't it? Wait, it will move. 1, 2, yeah, 3. You're right. So 1, 2, 3. Yes. So meaning 9.5 kilometers gives 9,500 meters. Did you see? From bigger unit to smaller unit, it's more because you multiply. Smaller unit to bigger unit, you divide. Correct? Now, 6 hours. Unit of time, right? And what is the SI unit of time? Second. So this is C, right? So 6 hours. So how many hours make 1 second?
How many seconds? 2,600.
So
2,600 seconds.
now, to do that, you have to convert from hour to minute, minute to second. Okay? Okay? So now, from hour to second, that is from bigger unit to smaller unit. Is it going to be higher or less? It's going to be higher, isn't it? Because hour is higher than second, isn't it? Correct? So now we can simply say times how many hours make 1 minute?
60 minutes makes 1 hour.
So we can say 60 minutes gives, oh, sorry, I wrote 6. I mentioned 60, but I wrote 6. So gives 1 hour, right? So, and then you see, this is 60 minutes over 1 hour. So see, the hour can cancel, isn't it? Now times what? From minute to second. 60 seconds over 1 minute, isn't it? Right? So you see, 1 hour cancel out, 1 minute cancel out. What are you left with? Seconds, isn't it? And this is what? 6 times 60 times 60, right? Which is what you mentioned, 6 times 3,600. Correct? So what do you have?
21,600.
21,600 seconds. Are you following? These conversions are very important. Okay, now we are taking our time bit by bit to, ensure that you get the basis. Okay, because once we start to solve problems, okay, we will not waste time on the conversions. Okay, we'll just be doing them and assume that it's already understood. The next one is 330 milliliter. Madam, milliliter is unit of what? Take the mic. Milliliter is unit of what? Mil. What we call mil, isn't it? Unit of volume. And what is the SI unit of volume?
Liters.
What is the SI unit of
Centimeters.
No. What is the SI unit of volume?
Milliliters.
No. Meter is unit of length, as you mentioned earlier, isn't it? You mentioned earlier. What is the SI unit of volume?
Liters.
No. Volume is like length times another length, isn't it? Length times breadth times height. What do you have as the unit?
Meters.
Meter cubed. Meter cubed. Okay, so the SI unit of volume is meter cubed, not liters. Okay, Even though liters is a metric unit. It's a metric unit. We are going to explain that in the next lesson. Okay. So the SI unit of volume is meter cubed, not liters. Okay.
So the question says
D.
3. We should find it in its SI unit. Milliliters. 330
mil or milliliter. It's
milliliters.
pronounced mil, usually, or in full, milliliter.
We are going to be using this.
1 meter cubed is equal to 100 milliliter. No. Or what's the relationship between 1 meter cube and liter? Meter and liter. What's the relationship?
100.
Meter and liter? Meter cube and liter, sorry. How many liters make 1 meter cubed?
Liters.
Yes, how many liters make 1 meter cubed? Because milli is simply exponential minus 3, isn't it?
Yes.
So how many liters make 1 meter cubed? That's the relationship that you have to remember.
Meter cubed over 1.
Hello. How many liters make 1 meter cubed? You don't know the relationship. It's 1000. I think I mentioned in the previous class, didn't I? Okay, but didn't you solve the problem?
Yes.
No. The SI unit is meter cubed. So 1 meter cubed, write it down. 1 meter cubed equal 1000 liters. 1000 liters. Okay, now this will be equal to how many milliliter? Okay, now how many one liter is equal to how many milliliter?
Liter.
Yeah.
Milliliter.
1 milliliter, 1 liter is equal to how many milliliter?
1000.
Good, write it down. Is equal to 1 liter. Okay, now what is the relationship? 1 meter cubed is equal to how many milliliter?
Meter cube is equal to.
This is, you multiply by this, isn't it? It's going to be 10 to the power of 6. 1 million milliliter. Isn't it? 1 meter cubed is equal to 1000 liters. And 1 liter, oh, I didn't bring my water bottle. Okay. 1 liter contains 1000 mil or milliliter. So 1 meter cubed gives how many milliliter? It should be 1000 times 1000. Correct? Write it down. So 1 meter cubed is equal to milliliter, which is 1 million, isn't it? Or 10 to the power of 6. Milliliter, right? Good. Write 1 meter cube there. Okay, now back to the problem, because you must first establish the relationship, okay, between the unit in question and the SI unit, isn't it? Once you have the relationship, the remaining, as they say, is quite easy done, isn't it? So now 330 milliliter is equal to how many meter cubed? Remember, now you are moving from smaller to bigger. Okay, from smaller, which is milliliter, to bigger, which is liter. Sorry, which is meter cubed. So how is it going to be? Smaller to bigger. Is it going to be bigger or smaller? Rioma. She's multiplying, so it's going to be bigger. It's going to be smaller. Remember the rule, isn't it? You are moving from smaller unit to bigger unit, isn't it? So you are not multiplying, definitely. Do you remember? When you multiply, you are now increasing the number, isn't it? So you are going to divide. You're going to divide by 1 million. Okay? Instead of multiplying by 1 million, okay? Over 10 to the power of 6. Okay? And what is the answer? What is the answer? You can make it in exponential because this is just like 33 times 10 to the power of minus 5. Yeah, that is 3.3. Yeah, that is 3.3. Okay, that is 3.3. I mentioned 33. Yeah, if it's 33, it will be to the power of minus 5. If it's 3.3, it will be to the power of minus 4. Do you understand? Did you see that this one gave you some tough time?
Yes.
Even though it's simple?
Yes.
All right, go and sit down. Now, hello. Mile.
Miles.
Yeah, 6 miles. Mile is what?
1,000 meters.
No, length, right? Okay. So, what is the SI unit of length? Meter. So, what's the relationship between mile and meter? That's the first thing you should establish, right? A mile, as we mentioned earlier, is the imperial unit or English unit, okay, of length. We can see that. Well, by the way, this 330 milliliter, does it ring any bell? These small water bottles, although here we don't have small water bottles, but you have small water bottles that are I mean, using this size, 330, which are very small. Okay, 330 ml. Okay, go ahead. 6 mile. Now, like I mentioned, you need to establish the relationship between mile and what? Meter, correct? So, how do you establish that?
1 kilometers equals to 1,000 meters. 1.6 kilometers equals to 1 mile.
Okay, good, good.
Therefore,
Now, 1 mile is equal to what in kilometer? Yeah, 1 mile. Sorry, in meter, because this is mile to kilometer, and you can see that from English unit to metric unit, because kilometer is a metric unit. We are going to explain that. You see 1.6. So the converging, you have to memorize certain numbers. But in metric unit, you use decimal. Like centimeter, you just 100 centimeter equal 1 meter, 10 millimeter equal 1 centimeter, like that. Okay, so it's easy to switch within the same within units of the same physical quantity using the metric system than when you have the English unit. Okay, but like I mentioned, unfortunately, most of the practical things you go out to do, I mean, even the speedometer, some are graduated in miles, especially those from the States. Or some now you see it in kilometer per hour and mile per hour, MPH, mile per hour, and then kilometer per hour. So go ahead. So how many miles now gives 1 meter?
therefore, due to my research, 1 mile equals to
1 mile.
yes, 1 mile equals to 1,609.34 meters.
How did you get that?
I searched.
Pardon?
I searched.
You searched?
Yes.
No, but when you search, although you are right, even though you see this one is actually 1 mile is equal to 1.609 kilometer. Okay, so it's simply multiplying, just like we did here. We multiply 1000 by 1000. Here you multiply 1000 by 1.6, which gives you 1600. Okay, but like I mentioned, the actual conversion 1 mile equal 1.609. Okay, so that is how it is obtained. So you can use the actual one 1609.34, because there are some decimal, or if you want to simplify it, you can make it 1600. Okay, okay, so 1 mile is 1600 meters. Now 6 miles equal what in meters?
Therefore, 6 miles
Mhm.
equals to um, 6 miles
Mhm.
equals to 6 times 1,600
Excellent, and that gives you what?
times 6.
That gives you what? 9600.
96.
Right?
Yes.
Because it's simply saying like 16 by 6, isn't it? Which is 96. Then you have two zeros. Okay? Meters. Excellent. Clear? Did you get it this way, Mariam? Dude, I'm not asking you because. Okay. Now you have. So, you see, with this one, you can do the same thing for acre, because for acre, all you need to do is the relationship, just like we did for this one. The relationship between acre. By the way, acre is a unit of what? Area. Excellent. Because when you want to buy a farm, it tell you how many acres of land or hectares. Okay, and all you need is the relationship between acre and meter. I think acre, 1 acre is 4087 point something something meter square. Okay.
40, 46
What?
40, 46
Oh, then approximately 40 47, right?
Yes.
Yeah, 40 47 meter square. Okay, and then you have 10 acre, so you multiply by 40 47, isn't it? Simple. The next one, 4 liters. That one will be simple, isn't it? Okay, because 1 liter, 1 meter cube is equal to 1000 liters. So 4 liters. So from liter to meter cube, you divide, isn't it? You divide 4 by 1000, isn't it? Which is 4 times 10 to the power minus 3 meter cube. 3/4 inch. 4 liter, like the gallon, isn't it? The gallon. The gallon is usually 4 liter, although they will tell you maybe you have US gallon and UK gallon, 4.85 or something like that. But usually it's approximately around 4 liters. 3/4 inch is like a pipe, small pipe size, okay? 3/4 inch, okay? Inch is a unit of what? Length. So you need to establish the relationship between inch and meter first, okay? First, how many inch? Inch to centimeter, okay? Okay, inch to centimeter, 1 inch.
0.025.
Inch to centimeter is about 2.54 centimeter, right?
Yes.
And then to meter,
0.
you divide this by 100, isn't it? Which gives you 0.0254, right? 1, 2. This is in meter. So 1 inch is 0.0254 meter. So what about 3/4 inch? So you see, inch, 1 inch, from inch to meter, that is smaller unit to bigger unit. You divide, isn't it? Yes. So you divide the 3/4, which is 0.75, over this one. Correct? Are you following? 5 feet, like height, isn't it? Describing height. Okay, 5 feet tall. Okay, the same thing. From 1 foot is around 0. What? 3048 meters. Okay, so what you need to do from smaller unit to bigger unit, so you divide 5 divided by this one, isn't it? Okay, no, from this to meter, right? So 5 divided by that. No, you multiply because it is this is 5 feet, isn't it? And 1 foot is 0.3048, approximately 0.3, isn't it? Okay, so you multiply. Okay, you multiply in this case, because if you multiply 5 by this, you get less number, isn't it? Okay, and then the last one, 120 kilometer per hour, which is the maximum speed on our roads is actually 100, not 120. But there in the kingdom, it's usually 120. On few roads, you have up to 140. Yeah, but sometimes you find people going to, cruising at 120 or even higher. Okay, so I think 120 will make some sense, isn't it? You will understand, cruising, let's say from here to Kaduna, when they're at 120, the speed, okay, because what kilometer per hour indicates what? What quantity? Per hour, yes. Is the unit of what? Kilometer per hour. Kilometer per hour. Of what? Velocity or speed, isn't it? So kilometer per hour is, and the SI unit is meter per second. Now, how do we convert kilometer per hour to meter per second, isn't it? We will soon reach, the speed, velocity, and what have you. So how do we now convert it? Okay. How do we? Because now we have to find, because this is a ratio. Remember the other conversion I did? So this is 120 kilometer per hour. We have to convert two things here, isn't it? Kilometer to meter, and what? Hour to second, right? So, who can do it? Who can solve this? You can solve? Okay, come and solve it. Take the mic. If you remember, I told you that the homework, you are not just going to submit it, isn't it? We're going to work it out with you, right?
1 kilometer equals to 1,000 meters.
Okay.
Therefore, 120 times 1,000 equals to 120,000. And
120,000 unit. What is the unit now?
120,000 meters
Per what?
per hour.
Good, because the hour is there.
Yes. And 1 hour equals to 3,000.
Can you see what she's doing? No, sir. Okay, go ahead.
And 1 hour equals to 3,600 seconds.
Seconds, okay.
Yes. Therefore, 120,000
meter per hour.
meters.
Okay, go ahead. Just do it.
Meters all over 3,600 seconds equals to 33.33 meters per second.
Per second. Okay. Let me see if we will arrive at the same answer. I will just solve it in few steps. Okay? Okay, go and sit down. Now, in my own way, I will just do it this way. 120 kilometer per hour. Now, I will just multiply, just like I did before. Okay? First one, converting kilometer to meter. So, 1,000 meter over 1 kilometer, isn't it? So that kilometer will cancel out, isn't it? Are you following? Times, now to convert hour, 1 hour is equal to what? 3,600 seconds, or 60 by 60, correct? So now, you see, in this case, I will have second as denominator, isn't it? Now, here you see, hour will cancel hour, kilometer will cancel kilometer. What am I left with? Meter as numerator over second, isn't it? And what do I have? I will have 120 times 1,000 over 3,600. Exactly what she did, isn't it? So I will have the answer as 33 0.33 meter per second. Okay, if your computation is correct. Do you understand? Okay. I think from these exercises you realize two things: the importance of change of subject of formula, isn't it? The importance of change of subject of formula and unit conversions, isn't it? The conversion of unit, it may appear to be like simple, but you have seen that, some can be a little bit tricky, isn't it? And in physics, we deal with physics with quantities, okay, with their various units. So more often than not, you find yourself switching or converting from one unit to another. And this is where you have to get it right, okay? And like I mentioned earlier, in our next class, which is lesson 3, we will now look at the different systems of units, okay? And the nomenclature, how to write them, and some rules about units, because units are very important. Like I mentioned earlier, like in lesson 1, if someone told you my weight is 50, you'll ask 50 what? Pounds, isn't it? Kilogram, or what, isn't it? So numbers alone, more often than not, don't make sense without attaching the appropriate unit. And that is why unit is very important. In physics, we deal with quantities all the time. Okay? So we cannot overemphasize on units. Okay? And then any question? Q&A? Any question on what we did so far? Are you sure? No question? All right. So see you in the next class for lesson 3. Goodbye.